Good morning, students. Now, as I discussed in the previous video lecture, that we will be discussing numericals based on friction. So today we'll be solving some numericals, and the very first numerical is based on the type 1 and type 2 type of frictional problems, that is no impending motion and impending motion. So let us read the first numerical, that is body of weight 300 Newton is lying on horizontal plane of coefficient of friction mu equals to 0.3. Mu equals to 0.3. If the external load P is 80 Newton, first find frictional force. Second, the external load P minimum. We will have to find P minimum to cause the motion. Here P makes angle 25 degree to the horizontal. It means this is the block, this is horizontal. Here P is making 25 degree and W is 300 Newton, 300, N is okay, we'll calculate N, and friction force. So first problem is find the frictional force if P is making 250 degree and P is 80 Newton. P is 80 Newton. 80 Newton. So if we'll now first type of problem, it means no impending motion. It means we'll have to just apply the equilibrium equations only without applying the frictional force equation. So two equations only, that is summation fx and summation fy. So friction force is to be calculated. It means P cos 25 equals to friction force. So P is already 80 Newton, 80, and cos 25. What is cos 25? Can calculate cos 25. Let me see. Cos 25 is 0.9063. That is 0.9063. So this will be the frictional force. This is frictional force. Okay. First answer you can calculate. Now second question says find P minimum to cause the motion. What is the P minimum to cause the motion? It means it is the case of impending motion. So third equation will come into picture, that is friction force equation, that is F equals to mu N will come into picture. So to solve this, calculate P minimum. Now here P is unknown, angle is 25 degree, this is 300 Newton, and normal reaction. P minimum, it means F should be limiting condition. F should be limiting condition. So first equation, FF equals to P cos 25. First equation. Second equation is FF equals to mu into N, and the summation Fy equation. Third equation will be equal to N equals to 300 minus P into P into P into cos sine P sine 25. P sine 25 is 0.4226. 0.4226. So this is third equation. So if you solve, we'll get P. So for simultaneously solving, you'll get P equals to 90 upon 1.03331, which is equals to 87.1 Newton. Answer. It means minimum amount of load which is required to cause the motion is 87.1 Newton. Now the second numerical is a body on a rough plane require a pull of 180 Newton at 30 degree to just move it. The same body require a push of 220 Newton at 30 degree to move it. We have to calculate the weight of the body and coefficient of static friction. So if you closely observe this problem, you will see that a body of some material, certain material, require a pull of 180 Newton to move it. On the other hand, it require a push of 220 Newton to move it for same configuration. It means it shows that a body is easy to pull than to push. So this problem is based on that concept. So it has two conditions. First is pull P 180 Newton at 30 degree, friction force. So weight is not known. This is first case. Second case is second case is -30° push. So in this case, friction will be in this side because it has tendency to move towards left. So the friction will oppose the motion and it will develop along the right direction, that is this direction as shown in the arrow. And again, its weight is not known, mu static is not known. Mu s will be same in both the cases. So we'll be solving the equation for these two different cases. Here one thing is friction force in case 1 will be 1, case 2 will be 2. So Ff1 will be equal to 180 cos 30, 180 cos 30, which is equals to 155.9 Newton. So friction force we have calculated. This is a case of, one more thing, this is a case of limiting friction. So friction force should be equal to mu into N. So before we go there, here N will be different. N will be different because push and pull will have different effect. Now pull will have different effect, push will have different effect. So reaction will be different in both these cases. So N1 will be equal to W. N1 will be equal to W minus 180 sin 30. N1 will be equal to W minus 180 sin 30, that is equals to W minus 90 Newton. Okay, and we already know that mu N1 equals to, and F1 equals to mu N1. So 155.9 equals to mu into W minus 90. So this is third equation. So we have W mu, we have W, N and mu here. Now consider this case, that is FF2 equals to 220 cos 30 which is equals to 190.5 Newton, and N2 equals to W plus P sin 30. P, that is 220. P is 220 sin 30. 220 sin 30, which is equals to W plus 110. W plus 110. W plus 110, and the force of friction F2 equals to mu N2. So 190.5 equals to mu W plus 110. So if you solve these equations simultaneously, you will get the value of W and mu. So let us divide this by this here. It means, let us solve here. That is 155.9 upon 190.5 equals to W minus 90 upon W plus 110. So if you solve, you will get W equals to, from this equation, W equals to 991.2 Newton. And if you use the W in any equation, you will get mu equals to 0.173. So we have solved W and mu as this one. Now the other problem is based on checking the tipping condition. So tipping condition, whenever tipping condition is asked, it means we will have to apply one more set of equation, that is moment equation. So the question says a uniform crate means a box, you can consider as a box. Crate is a box which has 196.2 Newton weight. If a load P is applied as shown, then find if the crate remains in equilibrium. Mu s means static friction equals to 0.3 and the dimensions in meter. The crate is 0.8 meter wide and if you see that point of application of this load, it is a kind of push, not pull. Point of application is 0.2. It is at 0.2 meter from ground and inclined at 30 degree. So moment equation will definitely come. Now, whether the crate remains in equilibrium or not, whether it is static equilibrium or whether it is tipping. So both these condition is needed to be checked. So let us examine this problem. So first, again, summation fx equals to 0, that is $80 cos 30 minus ff. Here this will be ff towards left. 80 cos 30 minus ff will be equal to 0. Summation fy will be now, since we will have to consider this point of application, it means let us again remember that previous point. We will have to consider n. That is, normal reaction is slightly shifted by x amount. So summation fy will be 0, that is minus 80 sin 30 plus NC is normal reaction, minus 196.2 equals to 0. And the third equation is moment equation. Let us take moment about point O. This is the point O. This is point O. If you take the moment summation MO equal to 0. So taking moment about point O, if you see, then weight point of application of weight will be passing through O, and this friction force is also passing through O. So moment at sine 80 cos theta 80 sin theta sin 30 into 80 sin 30 into 0.4 minus 80 cos 30 into 0.82 cos 30 into 0.2. This is moment due to y component of this load, and this is moment due to x component of this load. And plus NC into x equals to 0. So if you solve, you will get friction force equals to 9.3 Newton. NC will be equal to 236 Newton, and X is coming out to be minus 0.00908 meter, which is equals to minus 9.08 mm, and minus sign is coming. It means N is not moved towards right, rather it is shifted towards this one. So you can see again that NC will be this one. Okay, so this is the case, and since X is negative, it indicates that the resultant of normal force X to the left of the create center line, and no tipping will occur. No tipping will occur because X is less than 0.4. For tipping condition, X should be less than 0.4 mm, and X is less than 0.4 here in this case, so no tipping will be occurring because this amount is 0.4. So maximum X will be 0.4, and here we are getting X as 0.0000 this 908 mm, which is less than 0.4, so no tipping will occur. And you can also see that the friction force is 69.3, and maximum friction force FF max equals to mu Sn, which is equals to 0.3 into 236 equals to 70.8 Newton. So friction force maximum is limiting friction is 70.9, 70.8, and the friction force which is developed is 69.3 in this case. So the crate will be in static equilibrium because under the application of this much force P, we are getting friction force 69.3, which is below the limiting friction. Okay, that's it.